For question number 2, we know the function f(x, y). The entity function is 1 divided by a of y square x when y greater than equal to 1 and the x lies between 1 by y to y. The first part is to have to draw a non-zero definition region for function f of xy. This line is for x equal to y, and this part is x equal when x equal to 1 by I. So for the x part, the this shaded region is when x lies between 1 by y to y, and when because this line is x equal to 1 by y, so xy, so we can find xy equal to 1. So from this line upper hand, anything greater than any value of y should be greater than equal to 1. And this total part, we know that the x value is between 1 by y to y. So this part after the concave, this value which is satisfied by both y and x, so which is y greater than equal to 1 and x in between 1 by y to y. Second part, we have to find the value of a so that f of y is a valid joint density function. So to find the joint density function, we can write the formula f function of xy nothing but equal to this start from 1 to infinity, because the y value is greater than equal to 1. So and the x value is nothing but in between 1 by y to y. So integration of 1 by y to y, 1 by a y square x dx dy. So first we have to solve for x, then we're going to solve for the value of y. So for when you're calculating for the value of x, for that we have to consider a y square as a constant. A is a constant, but for a dx term we have to consider y square as a constant. So the integration of 1 to infinity, we put this part out because this is a constant part. So 1 by ai square whole into integration of 1 by y to 1 by x dx dy, which is nothing but equal to summation of 1 to infinity 1 by a y square, which is a constant, and we found the integration of 1 by x, which is a natural log of x, which varies from y to 1 by y. So the upper limit is y and lower limit is 1 by y. So by solving this part, means adding the value of y in place of x, we get 1 by a y square whole into ln y minus ln 1 by y dy. So now we eliminate the x. Now we have to solve this value for the value of y. By solving this one, by solving for the value of y, we get the final a value is 2. So the third part is we have to find the density functions for f of x and f of y, and we have to draw the marginal density functions for fx and fy. So to get the marginal density function for fy, so fy is equal to minus infinity to infinity the function of f xy dx. So we know the value of this part, which is the value of x lies between 1 by y to y, 1 by y square x dx. We remove the part of a because this one is a constant and we don't care about it. So by solving this one, you get ln y by y square. Similarly, when you solve for f of x, so we know the f of x has two value, which lies between 0 to 1, and another one is 1 to infinity. Because from this part we know that fx is lies between 1 by y to y. So xy equal to 1. So x varies from 1 to infinity. So x have two parts, one from 0 to 1, another one from 1 to infinity. So in first part, when x lies between 0 to 1, fx equal nothing but summation integration of 1 by x to infinity 1 by 2 y square x dy, which is equal to 1 by 2. and when x is between 1 to infinity, the f of x value equal to x to infinity 1 by 2 y square x. The 2 is come from a value, so we'll find out 1 by 2 x square. So from the f of y value we can draw this for ln y by y square. The graph will come like this, and because fx has two values, so this graph will go like this, and there is a certain drop because it's 1 by 2x square, and this part is fixed. The maximum value, the amplitude is 1 by 2. So the fourth part will be to calculate fx and fy both are valid density function or not. Because integration of 1 to infinity ln y divided by y square dy is equal to 1, so fy is a valid Fourier density function, but fx is not.